Hi, and welcome to this SATSOFT how-to video, where we'll illustrate how to set up sidelobe suppression as part of generating a contoured beam. As an example, we'll consider an analysis of a contoured beam over the contiguous US or conus as produced with a shaped reflector antenna model that was introduced to SATSOFT 3.2. There is an existing tutorial for this analysis, which is shown here. A 1.3 meter diameter reflector is shaped to generate the contoured beam over conus at 14.25 GHz. An edge of coverage contour of 31.34 dBi is drawn, and other lower lying contours at 15, 10 and 0 dBi are also shown. If we look at South America, we can see that the level is between 0 and 10 dBi on the northern part. And in this video, we'll extend the analysis to suppress the level of these side lobes while maintaining a high level over conus. Practically, this corresponds to the situation where conus is the surface area, while South America is a reuse area, an area covered by another antenna with the same frequency and polarization, on which the conus beam should have as low level as possible to reduce interference. To start the suppression analysis, we make a copy of the existing antenna 1 by dragging and dropping it onto satellite 1. We name the new antenna Antenna 2. We rename polygon 1 under Antenna 2 to conus. The conus polygon covers conus. For the side lobe suppression analysis, we need another child polygon, and we generate it by drag and dropping the conus polygon onto Antenna 2. We call this new polygon as conus South Am. So far, conus South Am is just a copy of the conus polygon, and we now want to add South America as another subpolygon. To do this, we click on Table Create in the right menu and change the input coordinate system to long lat. Then we go to an Excel spreadsheet in which we already prepared coordinates for the boundary of the visible part of South America. We copy this and paste it onto the table in SATSOFT and press OK. This creates South America as another subpolygon in conus South Am. We're now ready to set up the design and therefore go to the Antenna 2 view. Since this antenna is a copy of Antenna 1, it shows first the pattern of that antenna, and to perform a reflector shaping, we need to generate the initial defocusing ellipse as well as stations within the coverage. We right-click and select Beamlet and Stations Grids. In this dialog, we first use the conus polygon for generating the initial defocusing. As we want most of the antenna's radiation to fall on conus, this is a much better choice than using the conus South Am polygon. Next, we go to the Station Grid tab. Since we want optimization goals both over conus and South America, we here change the polygon to conus South Am, generate the stations, and press OK. We see that we, in addition to stations over conus, now also have stations over South America. All stations by default have a goal of 30 dBi, which is indeed what we want over conus, but we want to impose the side lobe suppression goal for the stations in South America. To make this change, press on Select Stations in the right menu and draw a box around all the stations in South America to select these. Then press on Edit Stations to the right. This brings up the Modify Station Weights dialog for the selected stations. To introduce side lobe suppression for these stations, we need to change the type of the copole goals from contour to side lobe. Also, we change the goal value to 0 dBi to try to minimize pattern levels to 0 dBi or lower over South America. With this change made, we're ready to make a design optimization. We first click on Compute Component Beams to generate the initially defocused pattern. This is the starting point for the optimization that we initiate by clicking Compute Composite Beams. This runs the optimization and generates pattern contours for the shape reflector with the same absolute level contours as for antenna 1 shown. The red contour is 0 dBi level contour that now passes north of South America, showing that the level over South America is below 0 dBi. It can be compared to the situation in antenna 1, where sidelobe suppression was not applied and where the level on the northern part of South America is between 0 and 10 dBi. If we go back to antenna 2, we see that the strongly suppressed the sidelobe level over the reuse area, South America. This doesn't come entirely for free, as we can see that the edge of coverage level has decreased from approximately 31.3 to 30.6 dBi. To be more quantitative, we can create a performance table by going to Tools, Performance Tables. In the performance table, the directivity at each station is shown in the rightmost column. If we press on this column's header, the table will be sorted in descending order according to this column. We can now look down in the table and search for an abrupt change of the directivity levels. It's easy to see that where this happens, it shows that the highest level over South America is minus 0.53 dBi, while the lowest level over CONUS is 30.56 dBi. So we have a suppression of 31 dB. Going back to the antenna 2 view, we have now performed a complete analysis in SATSOFT where sidelobe suppression was taken into account. This entire setup, including the antenna geometry and the design goals over CONUS in South America, can be exported to a complete POS project by going to File, Export File, POS project. Thank you for watching this SATSOFT how-to video. I hope you enjoyed it.